what you saw in the code, when you run compile it, you'll get graph like this. Is actually a multi-step agent already. And today we are going to equip it with Python executor. And with Python executor, the agent can write Python code that will connect to the Postgres database. And here it is. This is quite bang on. It has come up with a code that eventually give it the answer that, okay, the available databases in my Postgres SQL server is Postgres and Coffee Shop, which is correct. Hey there! If you enjoy my videos and find them useful, please help me reach 10,000 YouTube subscribers by subscribing and sharing this channel. It really encourages me in creating more AI and Gen AI content for you. You can also connect with me more on LinkedIn, GitHub, Substack, X, and Facebook. I share more about projects, insights, and updates there. Links are in the description. Moreover, I'm also building a crash course and a community about AI agents, a simplified version. Be the first to know and get an exclusive discount by subscribing to our YouTube channel and Substack channel. Links are also in the description as well. Let's start with the AI agent itself. We are going to make an AI agent with LangGraph. I choose LangGraph because I want control. I want to dig into the detail and implement the flow of my agent at will. There are many other multi-agent frameworks out there. LangGraph is one of them. You may want to choose other repos such as CrewAI, small agents, and AutoGen. And I believe those frameworks can also be integrated with the Open WebUI. And I think I will do a video on those tools or frameworks and how to integrate it with Open WebUI later. But today we are looking at LangGraph. All right. The way to do a multi-step agent with LangGraph is actually quite simple. This is just a very tiny graph that actually implement multi-step agent already. In this graph that you will make with the LangGraph, you will have the LLM node, and it's going to give you reasoning power. And it has autonomy to choose whether it's going to need to use tools that you equip it with in order to solve the answer, to solve the questions posed by a user, or it can just provide the answer already and end. So with this, it's actually a multi-step agent already. And today we are going to equip it with a Python executor. And with Python executor, the agent can write Python code that will connect to the Postgres database, as I'll show you today. And if you watch my earlier videos, these are the main components, at least the necessary components to enable multi-step agents. Memory, the React framework, forcing the LLM to reason and act and then respond. After that, you equip it with a tool and you have a loop, right? You want to give autonomy to the LLM to keep doing things before it can form a final answer. But you don't want it to get stuck in the loop, and therefore you have a termination criteria. Everything here is implemented with LangGraph so that you have a multi-step agent for you. Now, let's actually go to the coding section. This is going to be a little bit more technical. You can skim through to the next section that I will talk about Open WebUI and pipelines. But now, before we do that, we are going to demo how to create LangGraph agents in the coding walkthrough. All right, here it is. This is my repo that I prepare my LangGraph agent. So I did some architecture here. My agents will be kept in this folder. Other secrets and credential will be kept in the config. Tools, I will show you the local Python executor tool as well. I actually don't need the Postgres tool because the Python executor will do the heavy lifting in writing code and connect to the Postgres itself. So let's actually focus on how I define my data analyst agent with LangGraph. These are basic import stuff. You will import everything that you need. And I'll also import a Python executor from this file here. So let's jump into this file before we continue our agent. I need to thank the Hugging Face team, especially the small agent repo. I take this file from that repo. It's very nice and clean way to create a Python executor. You can define base built-in modules that the tool can access. You have many other helper functions, but what I like about here is it has blacklist some modules that local Python executor shouldn't do, so that you don't corrupt your environment. So if you take a look into small agents, it has a nice description of how to use this and what features it has. But basically, this is going to provide your agent with a Python executor on your local machine, and you have ability to say to authorize some imports, right? You can come to the end of the module here, and you can see that this is what we are going to use, the end goal class, but I'm actually using this one. So this encapsulate whatever it has in this file. It will trigger, it will instantiate a local Python executor here, provided you can provide it with an authorized import, and then it will execute the code. So all in all, this is going to be a function that I will give it to my agent to have access to local Python executor. And the way we are doing it here is we are going to import it to our agent module here. For this one is to actually load from .env file anything related to the environment variables, for example, OpenAI API keys that I have saved in the .env file somewhere here. Anyway, so this is just preparing my code for my agent. The default model name is GPT-4o Mini for now. This is my system prompts as a default. The agent will name Casey. She is an advanced data analyst assistant equipped with data analyst visualization and problem solving skills, and so on and so on. And I kind of like apply a React framework in the prompt here. It will force the AI to think and then determine what kind of actions or tool use it needs to conduct. And when the tool returns something to the AI, it becomes observation, and it will try to answer based on the observations, or it will choose to trigger multiple calls. And this is just a prompt. Now, I also provided with a default Postgres prompt to tell the AI, okay, if you are going to use a PostgreSQL database via Python executor, how to do it. For example, I give it an example that, okay, you might need to load the .env file in order to access the username and password to the Postgres server. The Postgres host is here, the port is there, and maybe you need to identify that, okay, I want the database called Postgres in order to list out what databases in there. But basically, this is a few short prompting. I give the model in the prompt, via prompt, some examples of how to do some task. This task is related to listing what tables are available in a particular database, right? These are two prompts. Vowels, we'll cover that later on, but what I want you to focus here is majorly about how to define LangGraph agent. I'm not going to do a detailed introduction because I am going to make more video on LangGraph agents specifically, or maybe a course. So don't forget to subscribe, and then you will get to learn a best practice course about how to create agents and stuff. But pretty much in LangGraph, if you want to have or enable memory for your agent, you need to uh, define a state. And this is my state. It's very simple state. It only has messages, and it's going to be a list of messages that matters here. This line is going to define a Python tool for my agent. Recall that I'm going to use this function imported from this file over here. Now, this is going to prepare a tool for my agents. This function is going to help me create an client to talk to ChatGPT, OpenAI server. So this is going to act as my LLM, large language model. The default is going to be, a client with this API key, and the model is going to be GPT-4 or Mini as a default. But I can pass many or other models name into it, like O3 Mini, for example. Now, those are just variables, definitions. The actual magic of creating a graph is contained in this function, create agent builder. Well, it takes LLM, tools, empty for now, and a prompt, system prompt. And you can see here that I combine the two prompts that I showed you earlier, the system prompt and the prompt to instruct the model how to use Postgres tools. Okay, well, moving on. This is just tools again. And this step, we are binding tools to the LLM. Now, the LLM is equipped with the tools. In this step, we are defining the node of the LLM. And the node is going to be named LLM node. The tools node is going to be called tool. And that's it. That's enough definition. Now we are ready to make the graph. The graph builder will be added nodes. The first node is the LLM node itself, and the second node is the tool nodes. And then we have a conditional edge that signal to the LLM node that you can choose to use the tool. But when the tool is used, it needs to return to the node. So this is an edge. This is conditional edge. And that's it. Once you have this builder, you compile it, then you get a graph that is this one. So basically, what you saw in the code, when you run compile it, you get a node like this. You get a graph like this. It's actually a multi-step agent already. All right, so let's actually give you a first demo. So this demo is going to be a very basic one. So let me just clear it and restart my kernel. Hopefully there will be no bugs. Otherwise, I am embarrassing myself to the whole world here. But anyway, let's go. So I import this. Now I have my LLM, and to show you my LLM is, I can run, LLM, and it's going to be a chat OpenAI API. We have a client ready, and our model is a GPT-4o Mini here. Now again, with the create agent builder, I provided with the LM that I want. I have a graph builder, but I need to build it. And the way to build it is to use a compile method. Inside the compile method, you put memory in it so that now the agent can keep messages with the LangChain or LangGraph backend. So I am going to define my agent, and the way LangGraph works with memory is you provide a config. Oh, this is just how the way it works. It handles chat sessions with thread. So pretty much use the same thread if you want to continue the same chat history before, or you can switch to other thread by providing it with a different thread ID. But let's just keep thread ID as 1 for now. Visualizing this graph, the graph now is here. So it's in the visualization. It ends with 700. So this one. So yeah, it's the graph that I showed you before. The reasoning node is here, and we are going to equip it with tools. It can choose to use a tool, or it can choose to give answer and end already. But when it's in the tool, when the state is in the tool node, it needs to return. It needs to return, no choice. That's why it's a solid line here. Back to the LLM node, who will decide whether it needs to trigger tool again or end and respond. All right. Okay. Just to kickstart with something here. So, okay. I am going to run this, and the question is a side of 60. Now, just to remind you that this agent is made from the Data Analyst agent, which already has access to the Python executor tool. So if the question is quite tough, well, side of 60, if you can remember, if you pay attention in school, it's square root 3/2. It's a simple or very repeated answers on the internet. So maybe I just need to test it out with like very crazy, difficult to remember answer. I don't know, like if this is going to be, who can remember this? I don't know. But so this is the way we want to test your function, right? Whether your agent, whether it can actually trigger the right tool calling or not. Now I have the responses back. Take a look into the message key here, and you can see that this is the information that you sent to OpenAI and you ask the model to do. So the second message is this guy. AI message content is empty, but you have other information that tells you that the AI thinks it needs to call a tool, and therefore the code that it wants to call is this one, import math sign of this one. And eventually, the tool provides back the answer of this much. Side of that much is this much. And with the tool response, the AI would then say, side of 20,000-ish is this. So you send the message to your AI agent. It decided to use a Python executor. It wrote a code, a Python code, and give it to the Python executor to execute, return a value, and then the AI grab that value and transform it into a final answer, right? I don't like to debug this, so I made another tool for myself to show it in Gradio. So I'm going to run this. It's going to import a class that I can use to run the code. And I can show you again here, but maybe with a different prompt. So let me just zoom out a little bit so that we can see the whole thing. All right, I'm going to ask, what is a log 10 of 1, 2, 3, 4? Hopefully it knows that it needs to use a Python executor again. Now, with the code that I wrote for the Gradio UI, I can toggle and hide information inside a tool call. This is neat. So it decided to use Python executor, and I want you to focus here. This is the way we define the local Python executor. You see this authorized import. So the AI knows what argument it needs to provide it for the authorized import to call this tool. And, it write the Python code to do that for me, man log 10 of 1, 2, 3, 4, and get the answer back. This is as simple as it is. You have a AI large language model. In this case, it's just the GPT-4o Mini, very, very affordable. You equip it with a Python executor, and it writes codes, trigger tools, get the answer. That's simple. The second example is going to extend what we did before by involving a database. So when we talk about database, let me show you the database that I have implemented. I have Postgres installed in my local machine. This is like a PG admin, and it allows me to serve a Postgres server locally, so that I can give you guys a demo. In the database in my server, there are two of them. The default Postgres database and the one that I made myself is a coffee shop emulator. Inside the coffee shop, I have three tables that matters. The transaction data, the store master, it will list, it will have like what stores I have, and the product master. So let me show you the product master. So I'm going to view all the rows here. My apologies, it's a little bit small, but you can see here in the bottom that I have product ID, product name, category, descriptions of the product, price, size, availability status, created at, updated at, well, a minimal version of the product master for your business, well, in this case, a coffee shop. And then I want to show you the store master. The store master, as the name suggested, contain information about stores. And in this minimal, I can, well, enlarge. Well, in this version, I have the store ID, store name, short address, like Union Park in New York. My branches are focused or located in New York City, the city that I like. Anyway, so this is the minimal version of the store master. And to show you the last one, the main one is the transaction data. So I am going to, show all rows. I think I have like about 3 million rows here in this transaction database. It will have a transaction ID. Each transaction ID is associated to one particular bill a customer buy. In the bill, you can have many products, right? And it's going to be encapsulated here. The way I do this is bill will have product IDs. It will have associated product price, the quantity, subtotal, and the total of the whole bill. This is the minimum version of the transaction data that I have. So what I want to show you here is how, with the minimal, very tiny agent like this one in LangGraph, where you equip it with the Python tool executor, you can have a data analyst working for you directly. All right, so first of all, let me execute this. This is just going to import. There's nothing much. Now, I want to show you explicitly that the system prompt now is a combination of the system prompt and the Postgres prompt that I divided and showed to you earlier. And I want to take this liberty to change it to GPT-4o mini because somehow I found that the O3 mini performed worse in writing codes. I think it can be because O3, the old version, is supposed to be for advanced reasoning, and somehow it's just an overkill for the application that we are going to show. Anyway, and also for cost-effective purposes, the GPT-4o mini is quite cheap too. All right. The way I constructed the Create Agent Builder allows for you to customize your system prompts. Even though the default is already this one, I'm just showing you the capability that it can do here. So I'm going to run this Agent Builder. All right, I've got the agent builder. Now it's time to actually build the agent. And the app is launched for the Gradio. So let's go. I'm actually going to copy this one, put it here. All right, this is the agent that we want. So let me try ask, what databases do I have in my Postgres server? Well, hopefully it's not going to embarrass me. But now it should be going through, well, it has a system prompt. The system prompt has an example of how to do this question. It should now go to that knowledge, provided knowledge via prompt, write code up, and try to solve this particular request. And now I'm seeing this and a little bit nervous. It's taking longer than I think it should, like 30 seconds already. Now I think it's doing so many rounds of React framework, and maybe because GPT-4o Mini is making mistakes and therefore it will need to redo many times. And now that I'm showing you, I think I'm afraid that I need to run this again. Actually, let me actually check whether it has an error or not. Nothing shows here, so okay. Well, uh, it didn't fail altogether, but there are so many tool calling. I think it made a lot of mistakes. Maybe like write a bad Python code and run into a problem. And eventually it seems you have to go on going shoes. It didn't do it well. So, well, that's too bad. Let me just ask it to try again. Unfortunately, well, this is probably or could be the limitation of the GPT-4o Mini, that it tends to make mistakes because it's not a bright and smartest model out there. But let's give it another chance. And if still we see the problem, I am going to change it to O3 Mini, or maybe yet a yeah, it's failed. So let me just go back and terminate this. Restart. Okay, I'm terminating that Gradio session, and I'm just going to go with the big guy here, GPT-4o. Restart again to give us some assurance here, and then I'm going to run through the whole list, and then we just refresh it here. Okay, what databases do I have access to in my Postgres server? A GPT-4o is much larger than the GPT-4o Mini, and I suspect it to run slower, but it should be more accurate. And here it is. This is quite bang on. Um, it has come up with a code that eventually give it the answer that, okay, the available databases in my Postgres SQL server is Postgres and Coffee Shop, which is correct. Well, the lesson learned here is for data analyst task, maybe opt out for the GPT-4o because you need a processing or brain power. And then I can ask again, what tables do I have in Coffee Shop? Hopefully it will write the correct Python code. And we are going to examine the Python code a little bit deeper this time to see how it does things. Here it is. This is the code that it has the GPT-4o thought that it needs to use. This one is going to load credentials from the .env file. This is import SQL alchemy. I specified it in the prompt that use SQL alchemy to access Postgres. And also, this is the .m location of the .n file that it thinks it needs to access. And then this one is it's going to get user name from the environment variables, get the password, and eventually create a client engine talking to the Postgres and get a table from using inspector get table name. This is bang on from the few shot examples that I gave it in the prompt. There's something fancy here. Now, the task that I will give it now is beyond the prompt. It's going to improvise on its own. I wanted to give list out columns in product masters. Now, this task is not included in the few shot examples in the prompting. So the LLM GPT-4o in this case has to come up with a solution on its own knowledge, and hopefully it will do the right thing. All right, the answer is product ID, product name, category, description, price, size, availability status, create at, update at, and well, let's actually check product master, and we are going to list out the columns. Here we go. We have pretty much the right one, right? So it's doing the right thing. It's doing it correctly. You can now ask whether it can aggregate. Well, let me ask it to what are date range? Well, what is the date range in transaction data? I created transaction data as a mockup data, and it ranges from the 1st of January 2024 to the last day of 2024. If it's if the GPT-4 can find the right answer, the right code, it will get to the right answer, and hopefully it will be done in a few seconds. And the answer is well, why is it this long now? To find the date range in the description in the transaction data table, I will query, and it's going to do that. Wow, this is bad. Wow. So I again I'm not going to provide some more hints. It should be able to do it on its own. And a few times that I did it on preparing this code, it was going to do it. It was able to do it. So this is the problem. You might run into a consistency issues if you write code or make some AI agents in the way that I just showed you. If you wanted to do a production level, provide it to your clients, rigorous testing, and maybe a little bit or much more control in how the agent will behave. This is not going to be acceptable, right? If you sell it to other customers, but for demonstration purposes, it shows the potential that you can now have a AI agent equipped with Python executor, and then it can act as a data analyst for you. Okay, it's getting pretty long. Now we ran into an error, and I think this is the recursion limit. It has reached a recursion limit, which is the default is 25. So yeah, I think we are kind of like bad luck today. We can try another run. But I'm going to skip another run for now because we will have another chance to do this task again when we integrate it with Open WebUI. So I am going to leave this as is for now. And one of the things that I can say is that you can now you may think of a way to increase or catch the recursion limit or increase it to something like 50 when it fails. This is like a retry mechanism that you might need to think of implementing. Okay, even though it's not successful run, it provided you with some example of what's possibility and how easy it is to construct a multi-step agent like this.